This question says, let f of x equal ln x and g of x equal 3 plus ln of x over 2 for x is greater than 0. Then it says the graph of g can be obtained from the graph of f by two transformations. A horizontal stretch by scale factor q, followed by a translation of h and then k. So question A says write down the value of q and then h and then k. So if we look at our original function we've got here ln x, and our new function g of x is equal to ln of x over 2 and then plus 3. So what we need to do here is to work out what this horizontal stretch factor is. So we should recall that anything horizontal occurs to x before it runs through the function. So any transformation horizontally occurs before we put the value through the function. So it's going to be something to do with this divided by 2 here. That's going to be the horizontal stretch. And because it happens before the function, we'd need to think what we'd need to do to return back to x here. So to go from x over 2 to x, we'd need to multiply by 2. So the horizontal stretch factor will be a factor of 2. So therefore q will be equal to 2. All right, next we need to look at the translation hk. So inside the bracket here we haven't got any plus or minus, so we've got no transformation horizontally. So the transformation horizontally h is 0, so h would equal 0. And then the k value will be vertical translation, and we can see here we've got this plus 3. So this is after we've carried out the function, after we've done ln of x, we've then added 3 to it, which would shift it vertically upwards by a number 3, so therefore k will equal 3. Alright, so next part of the question says that h of x equal g of x multiplied by cos of 0.1x for x is between 0 and 4. The following diagram shows the graph of h and the line of y equals x. So we'll scroll down so we can see that. Okay, so that's, and then we've got our graph here. It says the graph of h intersects the graph of h minus 1 at 2 points. These points have x coordinates 0.111 and 3.31, correct to 3 significant figures. Part B says, first of all, find the integral here. So what we need to do is enter in what the function g of x would be, which it says here is h of x times cos of 0.1x. If we go back to g of x, it would be this one here. So what we'd need to enter into our calculator, let's write that again, would be the integral between 3.31 and 0.111 of ln x over 2 plus 3, which is g of x, and then multiplied by cos of 0.1x dx. Enter that into your graphical calculator, and then that should tell you what that integral is. So I have done that with Wolfram Alpha here. So you can see I've got the definite integral here, exactly like I've stated. And it's told me, oh sorry, minus x, and it's told me that that is 2.724. So I've forgotten here on this one I should have the minus x. So let's just go back there, because you've got to do, yeah, I've forgotten about this minus x. So I need to write here minus x dx, and then that is equal to 2.72. Okay, then it says, hence find the area of the region enclosed by the graph of h and the graph of h minus 1, the inverse function. So if we come back to the graph here, we've got the line y equals x, and we've also got h. What we found here from our integral is h of x minus x. So this is the graph of h, and then we've done minus x. So what we've found is the equivalent of this area here between the two lines. Like that. Now, inverse function, h minus 1, to find the inverse function of a graph, what you do is you reflect the function in the line y equals x. So the inverse function is going to look like that, which would be a reflection in the line here. So the total area between the two curves, the area of the region enclosed by the graphs, would just be double this blue area, this red area here. So the answer I had from here, I would just need to multiply that by 2, and that would give me the answer. So it should be 2 times 2.72, which is going to equal 5.42. Okay. Next it says that D be the vertical distance from a point on the graph of H to the line y equals x. There's a point P, A with x coordinate A and y coordinate B, on the graph of H where D is a maximum. Find the coordinates of P where A is between 0.11 and 3.31. So, if I rub out what we had here. What it's talking about here is the vertical distance between this line and this line. So you can see here we've got the vertical distance, for example, here, 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 here. So it's talking about all these vertical distances. These would be D for different values of x. And what it wants to know is when D is a maximum. So in order to do that, what we need to think about is the function for D. So D is going to equal h of x minus x. So if we think what that function was, D is going to equal h of x was ln of x over 2 plus 3 multiplied by the cos of 0.1x, and then that's h of x, and then take away x. Now, if we plot this on a graph, on our graphical calculator, we should then look for where the maximum value of that is, and that should give us the maximum value of x. So we can stick that in. So again, I've used Wolfram for this. So I've plotted the function here. Here's the function up the top here, and then I've got the graph of it here. And as you can see, it passes through a maximum. And the way I've set it up is to work out what that maximum is, and it's given me the x value is 0.974. So using that, I've got that D max when x is equal to, and I've forgotten, 0.974. Okay, so that would give me the little value of little a. Okay, and then to get the value of b, I would then just need to place this x value into the function for h, so into this part, not the minus x, and that would give me this. Or alternatively, I could go back to my graph here, and I could read off the y value for this point here. Now, it will be able to give that to me because it's actually given me what the maximum point here of this is. That's the maximum value of d, and then I would need the maximum value of x together. So d max is 1.2, or 1.30. So if I write here, d max is 1.30, and then because that's the maximum value of d, this was the maximum value of x. The maximum value of x is obviously also going to be equal to the maximum value of y, because it's y equals x, and then I could add those two together. So b would equal 1.30 plus 0.974, which is going to be 2.27. So therefore p is equal to 0.974, 2.27.